This is a pre-college mathematics tape on sign rules in numerical expressions, Chapter 1. To make matters as simple as possible, I will explain how plus and minus signs in numbers affect answers. This is when arithmetic operations of addition, subtraction, multiplication, and division are applied. Only positive and negative counting numbers will be used in the demonstrations that follow. Positive and negative numbers, including 0, which is neither positive nor negative, are called integers. Integers are the numbers 0, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, and so on. So these are the kinds of numbers we will deal with in this lecture, and no other kind. The first thing we want to do is to show you how integers are added. For example, let's take 7 and 8. Minus 7 and 8, 7 and minus 8, and finally minus 7 and minus 8. The sum of 8 and 7 is 15. The sum of minus 7 added to 8 is 1. 7 added to minus 8 is minus 1. And finally, minus 7 and minus 8 equals minus 15. To reinforce the method of addition with integers, it is common to have students think about profit and loss, or deposit and withdrawal, increase and decrease, and so on. In the example above, let us assume that these represent temperatures, and that presently the temperature is 7 degrees. If there is a gain or an increase of plus 8 degrees, then the new temperature is plus 15 degrees. In the next example, if we begin, for example, as the temperature equal to minus 7 degrees, and the temperature goes up 8, then the temperature is equal to plus 1. Similarly, in the third example, if the temperature is presently 7 degrees, and we have a loss or a decrease in 8 degrees, the temperature presently would be minus 1 degree. And finally, in the last example, if the temperature is presently at minus 7 degrees and a loss of 8 degrees or minus 8 degrees occurs, the new temperature is minus 15 degrees. Addition of integers is the simplest concept in introductory algebra. In fact, we sometimes refer to these results, which take signed numbers into account, as algebraic sums. Next is subtraction. For example, I want to subtract the following: 8 and 15, minus 8 and 15, 8 and minus 15, we'll have several of these, minus 8 minus 15, 13, 4, minus 13, and 4, 13 minus 4, and minus 13 minus 4. Since the concept of addition is so simple, as I have said earlier, the usual procedure used in subtraction is to turn the question around to one of addition. And this is achieved in the following way, which we often refer to as the rule of subtraction. And this you should memorize. In your mind only, or as we often refer to it, mentally, in your mind only, change the sign of the bottom number this is the bottom number in this example. So in your mind only, change the sign of the bottom number to its opposite sign. In other words, the opposite to positive is negative. The opposite to negative is positive. But don't write those new signs in there because you're going to be changing the problem. Leave the signs as they are, but think of them as being the opposite. So, in your mind only, change the sign of the bottom number to its opposite sign and add it to the top one. So consequently, if you think of this as negative 15 and you add, then negative 15 and 8 will be negative 7. So that's the difference between 8 and 15. If you change the sign of the bottom one in your mind, we have negative 15 here added to negative 8, and that's negative 23. If you change the sign here and add, you have plus 15 and plus 8 is plus 23. If you change this one to positive 15 and add, the answer is positive 7. Here, if you change this to a minus 4 in your mind and add, the answer is 9. Here it'll be minus 17. Here it'll be plus 17. And here it'll be minus 9. The operations of addition and subtraction, written vertically as they are in my examples, are often referred to as vertical addition and subtraction. In this case, it's vertical subtraction. We will show how addition occurs horizontally. You will encounter the same questions written horizontally as in the examples which follow. 7 plus 8 equals 15. Here, the operation is to add. In the next example, we have minus 7, add 8, and that is equal to 1. Here is the add symbol for the operation add. These are the same questions that we did earlier in vertical addition. Here's another one of the examples. We had 7 plus negative 8, which equaled negative 1. Here again is the add operation indicated by that plus sign. And the fourth example that I used was minus 7 add to minus 8, which, if you recall, was minus 15. And again, this plus sign serves as an add indicator. We have then the following signs in these examples. The signs which are circled in red are operation signs, whereas the signs in front of the numbers themselves, like here minus 7 and here plus 8, are the signs of the numbers. These are the signs that are placed as part of the integer. To simplify matters when dealing with horizontal addition and subtraction, when signs run in sequence, The normal procedure is to reduce this condition to a single sign. For example, as I have shown earlier, that when dealing with 7 plus 8, we just write this as 7 plus 8 and not worry about the fact that each of these have plus signs in front of them. Another example that I had done earlier is this one, which is simply minus 7 plus 8. And that's the 1. And then we had plus 7 plus minus 8, you see. And that again would simply be viewed upon as equaling 7 minus 8, which is minus 1. And finally, minus 7 plus minus 8 would be expressed as minus 7 minus 8, and that's minus 15, as before. The next example will deal with horizontal subtraction, or subtract horizontally. Take 8, subtract 15. Here we have the operation indicated by this subtraction sign. So the sign itself conveys the idea that we want to subtract those two numbers. Another example we did before was minus 8 subtract 15, or plus 15. Here again, this sign conveys the operation intended. Another example we had was 8 subtract negative 15. And finally, we had negative 8 subtract negative 15. So what I have circled is the sign of operation indicating what to do with those two integers. The signs in front of the numbers are, of course, the signs belonging to the numbers, and the results are integers. Now, when we took 8 and subtracted 15, recall that we changed the sign of the subtrahend, which is the number here. When written vertically, it would be the bottom number, but horizontally, it's this one here. The sign changes to its opposite. And so, in order to follow this suggestion, as I've written here, when signs run in sequence, the procedure is to reduce the expression to single signs. What we want to do is rewrite this as simply 8 minus 15. Recall that was equal to minus 7. In this case, we would want to write simply minus 8 minus 15. Change the sign of the subtrahend to its opposite, which makes that minus 15. And when you add minus 8 and minus 15, you would end up with minus 23. Similarly, we're subtracting, so change the sign of this number to its opposite, and we would write 8 plus 15. And 8 plus 15, simply add, and the result is 23. In the final example, change this. This is the operation indicating subtraction. This sign should change to its opposite, and we simplify this to minus 8 plus 15, and now we add, and the sum here is equal to plus 7. Next is multiplication. Let's take 7 times 8, negative 7 times 8, 7 times negative 8, and negative 7 times negative 8. You'll have to learn some sign rules regarding multiplication of integers. When you take a positive number 7 and multiply it by a positive number 8, the answer is positive 56. A positive multiplied by a positive results in a positive answer. Negative 7 multiplied by positive 8 is equal to negative 56. A negative multiplied by a positive number always results in a negative number. In this example, we have the same kind of situation regarding signs, except the 8 now has the negative sign and the 7 is positive. But nevertheless, the answer is still negative 56. A positive times a negative is equal to a negative number. And finally, negative 7 times negative 8 is positive 56. A negative multiplied by a negative is equal to a positive number. We often learn these rules by just looking at the signs themselves. In other words, we look at signs and establish rules regarding the signs themselves, as I said, and ignoring the numbers when applying these rules. What I'm simply getting at is that a plus multiplied, the dot means times, by the way, times a plus is equal to a plus answer. A minus times a plus is equal to a minus answer. A plus multiplied by a minus is equal to a minus answer. And finally, as in the last example here, minus times a minus is equal to a plus. You will have to memorize those rules. Here are some more examples. A 4 multiplied by a minus 7 multiplied by a minus 2. This time, by the way, I am using brackets with no signs in between the closing and opening bracket here to indicate multiplication. This is the third example that I've used so far to indicate multiplication. Here's a times sign to indicate multiplication. Here is the dot to indicate multiplication. And here is the set of brackets that indicate multiplication. Now, look at the signs in front of the integers. And notice that we're going plus times a minus, followed by times a minus. There are two minus signs here, so if they're multiplied, the result will be a positive number. And so positive times the positive number, which is here, is going to end up into a positive number. We therefore have, in this example, the number 2 as the result. We can state a general rule regarding multiplication of several integers and the signs that are in front of them. I'll leave that to another after I've done a few more examples. In another example, if I have negative 2 multiplied by 3 multiplied by 0, anything multiplied by 0 is going to result in 0, so that's an easy one. And finally, in this example, I have negative 1 times negative 1 times negative 1. Notice that there are 3 negative signs in this indicated product, and if you take a negative times a negative to get a positive answer, of course that's positive 1. And then you take positive 1 times a negative 1, the answer will be negative 1. And the rule that I was referring to is the following. If you have an even number of negative signs in a sequence of operations involving multiplication, then the answer will always be positive. And if you have an odd number of negative signs in a sequence of numbers that are multiplied, the result will always be negative. So let's write that down. A sequence of even negative signs, I'll use any G for short, for negative, in a multiplication results in a positive, I'll use POS period for that abbreviation, in a positive sign. If the sequence is odd negative signs, then the result is a negative sign. For odd number of negative signs, the result is negative. The next is division. In division, if we have plus 1 divided by plus 1, the answer will be plus 1. If we take minus 1 divided by plus 1, the answer is negative 1. If we take plus 1 divided by negative 1, the answer is again negative 1. And negative 1 divided by negative 1 is positive 1. Now, the way we normally remember these rules is to simply use the signs themselves and ignore numbers. In other words, the rules for division are normally thought of this way. Here we have a positive sign divided by a positive sign is equal to a positive sign. A negative sign divided by a positive sign is equal to a negative sign. That one there. A positive sign divided by a negative sign is equal to a negative sign. And finally, a negative sign divided by a negative sign is equal to a positive sign. That one there. For example, if we have 56 divided by 7, the answer is positive 8. If we have minus 56 divided by positive 7, the answer is negative 8. If we have 56 divided by negative 7, the answer is negative 8. Negative 56 divided by negative 7 is equal to positive 8. Here are more examples. If we have 42 divided by 3, the result is equal to 14. Negative 42 divided by 3 would equal negative 14. If we have negative 36 divided by negative 9, the answer is positive 4. If we have 0 divided by 8, 0 divided by 8 is always 0. Another example, if we have 35 divided by 0, the answer is undefined. This cannot be solved, and it does not have any answer whatever. We simply refer to this quantity as undefined. Division by 0 is undefined. But 0 in the numerator, or in this part of the problem, divided by a number is 0. Similarly, 0 divided by 0 is undefined.